morning, everybody. So today I'm going to teach you about recursive formulas. And you might remember a little bit about a recursive formula from way back when in Algebra 1. Okay, so the first thing that we're going to talk about is the set of positive integers represents the position of the term in a sequence. So say I had the sequence 2, 4, 6, 8. This would be the first term, this would be the second term, this would be the third term, and this would be the fourth term. So I could write this as the first term has a value of a 2. If I were looking at this term, right, so this is the domain, it's the position of the term, and this is the range or the value of the term. And usually when we're writing out a sequence, we start with a domain of positive integers. So that means that my first term we start by writing as using this value of a 1 here, and then we go up by 1 each time. So this would be my second term, my third term, my fourth term. You're never going to have something like the 2.5th term or anything like that. The position of the term has to be a positive integer. Okay, so sometimes instead of using a subscript like we just wrote out, that my a sub 1 would mean my first term, a sub 2 my second term, a sub 3 my third term, and so on. Sometimes we use function notation to write that out. So instead of the a with the subscript of a 1, you could see it written like that. Like this. So if you're thinking about the general term of a sequence, we use the subscript a sub n, or in function notation, it would look like that. Sometimes they use the letter f of n instead of a of n. Okay, so this process of recursion can be thought of as climbing a ladder. So to get to the third step, you have to be on the second step. Each rung on the ladder depends upon stepping on the rung below it. So suppose you start on the first rung on the ladder here, right? A sub 1. You have to step up or add some amount to get to the next step. From the second rung, you have to step up or add some amount to get to the third step. So you can't go from step 1 to step 3 right away. You would have to go from step 1 to step 2 to step 3. Okay. So if you look at this table, you want to look at the term in front of the given term first. So if you have the third term, you can find the fourth. If you have the a sub n minus 1 term, you can find the a sub n. A sub n term, you can find the a sub n plus 1. And so on and so forth. A sub n plus 3, you can find the a sub n plus 4. Right? If you know that you have the third, if you add 1 to the subscript of a 3, that's how I'm getting the 4. If you know you have the a sub n minus 1, if I had added 1 to the subscript, you would get a sub n. You can only find the next term from the term that you have. Okay, so let's look at a question. So we have this recursive formula. Here's our formula. And this is saying that our first term has a value of -2. And we have to find the first 4 terms of the sequence, right? So they're using this function notation here. So my first term has a value of a -2. I need to find the value of the second term, the value of the third term, and the value of the fourth term. So I'm going to do that by using my formula. So here's my formula here. So if I know the value of the first term, I can only find next the value of the second term. So that means here, I'm going to plug in a 2. So anywhere I see an n in my formula, I'm going to plug in a 2. So this is a 2, this is a 2 here. So I have f of 2 equals f of 2 minus 1 plus 5. So f of 2 equals f of 1 plus 5, right? But I know the value of f of 1. f of 1 is a negative 2. So I'm going to cross this out and put negative 2 here. Negative 2 plus 5 is 3. So the value of my second term is a 3. Now that I know the value of my second term, get rid of this, I'm going to find the value of my third term. So anywhere I see an n in the formula, I'm going to plug in a 3. So f of 3 is equal to f of 3 minus 1, which is really f of 2, plus 5. But I know the value of f of 2 is a 3. So right here, I'm going to replace that number with a 3. So f of 3 is 3 plus 5, which is 8. And now I need to go find the fourth term. So where I see an n, I'm going to plug in a 4. So f of 4 equals f of 4 minus 1 here, which is 3, plus 5. But I know the value of f of 3, it's 8. So I'm going to replace this f of 3 notation with the number 8, and 8 plus 5 is 13. So now I know the first four terms. They're negative 2, 3, 8, and 13. Okay, so let's take a look at exercise 2. So we have to use this recursive formula to find the third term. So we're really looking for this term here. Now, we can't go right from knowing the first term's value, which is a 2. First term is a 2. We can't go right to the third term. We need to know the value of the second term first. So I want to think about this formula now. I want this whole exponent here, or this whole, I should say, subscript, to say a 2, right? Because I want to find the value of the second term. So in order to get that subscript to say a 2, really for n, I need to plug in a 1, because 1 plus 1 would be what gives me a 2. So anywhere I see an n in my equation, I'm going to plug in a 1. So I'm just going to rewrite this. This is a sub 1 plus 1, which would make 2, equals 2 times a sub 1 to the negative 2. Now I know the value of a sub 1, right? That's a 2. So I'm going to rewrite this equation. And where I see that a sub 1, I'm going to replace it with the value that I know that it is. It's a 2. And evaluate. So 2 times 2 to the negative 2 is like saying 2 times 1 over 2 squared, which is 1/4, which gives me a half. Okay. So now I know the value of the second term is a half. So I'm on my way to finding the value of the third term. Right? So I'm going to go back to my equation, my formula, I should say, and I'm going to look here, and I'm going to say, okay, I need this little subscript now to say a 3. So what plus 1 gives me a 3? That would be a 2. Right? So anywhere in my formula that I see an n, I'm going to plug in a 2. So this would really be a sub 2 plus 1, which is a sub 3, equals 2 times a sub 2 to the negative 2. Now I know the value of the second term, right? That was over here. That's a 1/2. So this is 2 times a half to the negative 2. This is the value of my second term. So 2 times 2 squared, that's 4 times 2 is 8. So now I have my answer. They wanted the value of the third term. The value of the third term is 8. And you do need to show work for open-ended questions. So I would expect to see everything I have here for question number 2 on paper. Okay, now let's look at question number 3. Sometimes you're asked to write a recursive formula, and you have to make sure that you include a starting value. Right? So for both part A and part B, I'm going to say what the value of my first term is. And now the next part is you want to look at the pattern. How do I get from -1 to 9, 9 to 19, 19 to 29, and 29 to 39? So hopefully you see that the pattern is an add 10. So what I'm going to say is I'm going to say to get to the next term that I want, I'm going to take the term before it and I'm going to add 10. This together would be considered your recursive formula. If you look at part B here, hopefully you can see the pattern is multiply by a third. Right? You might be thinking divide by 3, which is also correct, but we want to think about the pattern in terms of multiplication. So now I'm going to write my formula. So to get to the next term, I'm going to take the term that I have, or the term before it, and I'm going to multiply by a third. And this together would be my formula. So around the room, you should see a scavenger hunt. In your packet, there should be box paper. So if you scroll past the practice and scroll past the maze, I believe, there should be, a scavenger hunt recording sheet. If you could work on the scavenger hunt around the room, that would be great. The answers are posted on Canvas. There's also a maze in your packet that you could try, and the answers are posted on Canvas to that as well. Thanks, everybody. Have a good day.